Article 450.10 requires that secondary conductors of a transformer be protected from physical damage. This can be achieved by using a variety of methods, including installing the conductors in a raceway. Article 350.8 allows conductors to be installed in raceways. Article 362.10 requires that conductors installed in raceways be protected from physical damage. This can be achieved by using insulated throat chase nipples, lock nuts, and insulated bushings. Therefore, the proposed method of installing the secondary conductors in a raceway is code compliant. When connecting the secondary of a 500 kV amps 480 volts to 120/208 volts transformer to the main, disconnect with only 14 inches of space. Using a flexible conduit with connectors can be difficult. An alternative method is to use a 12-inch by 12-inch by 3-foot trough with a cover. This trough can be connected using insulated throat chase nipples, lock nuts, and insulated bushings. This connection method is code compliant according to the National Electrical Code. The primary concern in this scenario is protecting the secondary conductors from physical damage as required by Article 450.10a. A raceway provides this protection. Article 350.8 permits the use of raceways for conductor installation, and Article 362.10 mandates the protection of conductors within raceways, which can be achieved with insulated components. This solution is suitable where space is limited and a more rigid connection is feasible. When installing electrical systems, ensure all connections are properly grounded and bonded to prevent electrical hazards. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects non-current carrying metal parts together to create a low impedance path for fault current. The size of the grounding and bonding conductors must be appropriate for the size of the overcurrent protection device. Check the appropriate tables in the National Electrical Code for proper sizing. Proper labeling of all electrical equipment is essential for safety and maintenance. Labels should clearly identify the voltage, amperage, and other important information about the equipment. Additionally, warning labels should be placed in areas where electrical hazards exist. Regular inspections of electrical systems are necessary to identify and correct any potential problems. Inspections should be performed by qualified personnel and should include a visual inspection of all equipment, as well as testing of circuits and devices. Any damaged or worn equipment should be replaced immediately. Safe work practices are essential when working with electricity. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves, eye protection, and insulated tools. Follow lockout/tagout procedures to ensure that circuits remain energized while work is being performed. Proper ventilation is crucial in electrical rooms to prevent overheating of equipment. Overheated equipment can fail prematurely and can also pose a fire hazard. Ensure that electrical rooms are adequately ventilated and that air intakes and exhausts are not blocked. Surge protection devices can help protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices should be installed at the service entrance and at individual pieces of equipment. Arc flash hazards are a serious concern when working with energized electrical equipment. Arc flashes can cause severe burns, blindness, and even death. Perform an arc flash hazard analysis to determine the appropriate personal protective equipment required for working on energized equipment. Follow all safety procedures to minimize the risk of arc flash injury. Consider using a wire bending space that complies with NEC Section 314.28. Wire bending space is the amount of space required to properly bend and terminate conductors in an electrical enclosure. Insufficient wire bending space can make it difficult to install conductors properly and can also increase the risk of electrical shorts. Refer to the NEC for the minimum wire bending space requirements for different conductor sizes and enclosure types. Always consult the latest edition of the National Electrical Code (NEC) and local electrical codes for specific requirements and regulations regarding electrical installations. Electrical codes are constantly evolving, and it is important to stay up to date on the latest changes to ensure that your installations are safe and compliant. Consider using a licensed electrical contractor for complex electrical installations. Licensed electrical contractors have the knowledge, experience, and equipment necessary to perform electrical work safely and in compliance with all applicable codes. Hiring a licensed contractor can help ensure that your electrical system is installed correctly and that it will operate safely and reliably. During the installation, ensure that the conductors are properly supported and secured to prevent them from becoming damaged or dislodged. Use appropriate cable ties, clamps, or other securing devices to support the conductors. Avoid running conductors in areas where they may be exposed to physical damage or excessive heat. Conductors should be derated based on the ambient temperature and the number of conductors in a raceway. Derating reduces the ampacity of the conductors to prevent them from overheating. Refer to the NEC for derating factors and procedures. When connecting conductors to terminals, ensure that the connections are tight and secure. Loose connections can cause overheating and can also create a fire hazard. Use a torque wrench to tighten connections to the manufacturer's specified torque value. Properly terminate the conductors by stripping the insulation to the appropriate length and using the correct type of connector for the conductor size and material. Improperly terminated conductors can cause electrical problems and can also create a safety hazard. Always double-check all connections to ensure that they are correct and secure. A mistake can have serious consequences. After completing the installation, test the system to ensure that it is working properly. Use a multimeter to check voltages and currents, and verify that all circuits are functioning as intended. Look for any signs of overheating or other problems. If you find any problems, correct them immediately. Keep accurate records of all electrical work that you perform. These records should include the date of the work, the type of work performed, the materials used, and any test results. These records can be helpful for future maintenance and troubleshooting. Educate yourself about electrical safety. The more you know about electricity, the safer you will be when working with it. Take electrical safety courses and read books and articles about electrical safety.